All right, well, we are going to begin with another review exercise. So turn in your text or in your review exercise speed drill booklets to page 28, and let's take a look at exercise 33. Talking some more practical math, and one of the things that you'll want to do as you get older and begin buying groceries and stuff, if you're poor. If you're rich, it doesn't matter what, you just go buy whatever you want and have fun being rich. But for those of us who are not independently wealthy, we look at how much something costs versus how big it is. For instance, if I just said a jar of peanut butter is $5, well, if it's a great big jar of peanut butter, that's not too bad. But if it's a little tiny jar of peanut butter for $5, now I feel like I'm getting ripped off, right? So it's not so much how much something costs, but how much something costs for the amount of stuff you get. And so unit price, you see there on the exercise, refers to the cost of a single pound or a single ounce of a product. Now for groceries, it's usually by the ounce. It says comparison shopping involves choosing to buy a product that has the lowest unit cost. Often buying a large quantity of something allows a customer to get a lower unit price. So you might go to the store and be like, okay, here's a jar of peanut butter that costs $5. Let's just take an easy number. Here's a jar of peanut butter that costs $7. But if the $7 jar of peanut butter is twice as big as the $5 jar, you're better off spending the $2 extra and getting twice as much for not twice as much money. Does that make sense? Like, that's real easy numbers. It never works out to that easy of a number, but $5 jar, twice as big should be $10. But if it's only $7, hey, that's cheaper. Does that make sense? Okay, you can do this with buying flowers for Mother's Day for your moms, coming up in less than 2 weeks. And if you want to buy flowers for your mom, it's like 1 dozen roses, $50. 2 dozen roses, $60. 50 for 12, 10 extra bucks, I get a whole nother dozen. Okay, it's not quite those prices, but you get the idea, right? Well, I mean, if you want the vase and the note and the chocolates and all that, it get pretty expensive. Wait till you're independently wealthy to do that. But does that make sense with the idea of comparison shopping, right? If I'm going to spend money anyway, let me spend less per item or less per ounce. And that's what your exercise has you doing here. Now, because Choosy Moms Choose Jif, we've got some examples of Jif peanut butter, and these are actual costs as of a year ago. And so what I'm going to have you do is find the cost per ounce to the nearest tenth of a cent for 3 different ways you can buy Jif peanut butter, and then determine what's the best deal. So exercise 33, you're going to do some division. You may want some extra paper, or I was able to fit it in the little space between the problems. It's up to you. 3 problems and then a decision to make. You may begin. For unit price to find per ounce?
Oh, my mind blanked.
Now, if you're told how much per ounce you would multiply, if you're finding the amount per ounce you buy. And again, notice you're not dividing until it finishes working out. You divide to the nearest tenth of a cent. So, only to the nearest tenth of a cent. Otherwise, we'll be here all day. Tenth of a cent would be the 3rd decimal place. Tenth of a cent. Remember, cents already have 2 decimal places. So then the 3rd digit would be the tenth of a cent, and the 4th digit is what you would need to round the tenth of a cent. Go ahead and put your pencil down even if you are not finished. Let's take a look at this together. It says, first of all, a 16-ounce jar of Jif peanut butter costs $2.22. Find the cost per ounce to the nearest tenth of a cent. Lana?
0.14.
Well, 0.14 means 14 cents. Right, that's what 0.14 is, right?
Yeah.
Tenth of a cent.
13.8.
There we go, 13.8, blah, blah, blah. Actually rounds, I think, to 13.9 cents, because if you get after the 8, I think it's a 6 that would come next, 6, 7. Maybe it's the 7 that comes next. All right, but 13.9 cents per ounce. Does that make sense? Tenth of a cent.
I thought that's what it was, but I was still confused.
Yeah. All right, so on the next one, a 28-ounce jar of Jif peanut butter costs $3.84. What's the unit price to the nearest tenth of a cent?
13.7.
13.7 cents per ounce. Now, frankly, class, when it's that small of a difference, am I really saving that much by buying the bigger container? Not at 0.2 cents an ounce. Okay, how about the next one? A twin pack of 40-ounce jars, that's 80 ounces total, costs $9.77. That's a lot of money for peanut butter, but it's a lot of peanut butter. Find the unit price to the nearest tenth of a cent.
12.2.
That comes to 12.2 cents. Now that is a pretty big difference. So, Lana, which is the best deal for the Jif peanut butter?
The twin pack.
The twin pack of 40 ounces, the 80 ounces of peanut butter is the best deal. Questions on unit pricing and how all of that works. Now, the good news for you, because remember mathematicians are lazy. How many have been to Walmart, you've looked at the price tags? They're yellow, right? And the yellow price tag, for instance, might say $9.77 on it. And there's usually a little orange box in the corner. And you'll see the unit price in the little orange box. Now, there are times where it doesn't work for some reason, like they put like, instead of price per ounce, they do price each. And it's like $9.77, $9.77. I'm like, oh, they did price each. That's so stupid. That's not unit price. But most items, you'll see the unit price up there, which means you don't have to carry a calculator or do math in your head. They've already done the math for you. So you're looking at the 3 sizes of peanut butter, and the one was $2.22, and that was 13.9. The next was $3.84, and that was 13.7. Are those the right numbers from the exercise?
Yeah.
So you're looking at the little jar of peanut butter. You're looking at the big jar of peanut butter, and then the twin pack. And you're like, which should I buy? That's the least money, that's the most money, but look at the unit price. Am I really gonna eat that much peanut butter? If not, just buy the little jar. But if you're gonna say, no, I'm gonna eat a lot of, I love peanut butter, buy the big thing of peanut butter, save money in the long run. All right, questions on unit pricing. Any questions? Yes, sir.
How are like those two the smaller prices? Because that's 12.2 cents
Per ounce, but there's 80 ounces here. Here there's 28 ounces. Here there's 16. You're dividing. So to unit price is to take the price divided by the number of ounces. So even though this is a really big price, you're dividing by 80 ounces. Here you're only dividing by 16. Does that make sense? All right, good, good. Any other questions on this? Again, practical real life math. Yes, ma'am.
When we go to Walmart, my mom sometimes tells us to look at that to see which one's a better deal.
So you're already used to looking at that. Yeah, we'll do the same thing. Like for instance, okay, now I'm picky on peanut butter. I do not do store brand peanut butter. My wife tried it one time. I'm like, no, don't do that to me. Don't do Jif. Okay. And but you know, there's some things you can buy Great Value brand. It's like it's worth it. You know, or Publix brand. Because you know, you're like, okay, for instance, here's the Jif, and then right next to it is 16-ounce peanut butter, and it's $1.91, and it's what is that per ounce? It's I don't know. Let's just make up a number and say it's 11.7 per ounce. Like, see, big savings. Buy the Great Value. I'm like, I don't care. I hate Great Value. Give me Jif. Don't buy anything else. And I still spend the extra on peanut butter. But there are a lot of things we'll buy. Great Value. Yeah. All right. I got spoiled as a kid. We always had Jif. All right. Questions on this? All right. Let me go and collect that from you. Take your homework out. Books open to page 526. Books open to page 526. And we have a quiz coming up here in just a few minutes. Want to review over a couple of things before we take that quiz, and those things were in your homework. So, books open to page 526, and you had homework numbers 1 through 12. You had some radicals that you were asked to simplify and then add if you could. And then you had some pure quadratic equations that you were supposed to solve. For sake of time, I'm going to go ahead and read the answers. Make note if you missed any, we'll go over those. All right, so number 1, they are not similar, so you cannot add them. We move on. Number 2, they are similar, so you add them to get 7 times the cube root of 3. Number 3, they are similar, so you add them to get 3 times the square root of 10. Number 4, they aren't similar at first, but when you reduce the second one down, factor to 4 times 10, you get 2 times the square root of 10, which adds to the other 2 square root of 10, you get 4 times the square root of 10. 4 times the square root of 10. Number 5, they are not similar. You can reduce the second one to 2 times the square root of 7, but they're still not similar, so you can't add them. And number 6, they are similar once you reduce them down. I want to take a look at this one on the chalkboard. We've got the cube root of a 16x squared trying to add to the cube root of a 250x squared. Remember, for a cube root, you want to factor into a cube like 8 times something else to get 2 times the cube root of 2x. Well, once you get a 2x squared, excuse me, 2x squared, once you get a 2x squared here, assume maybe a 2x squared here. And yes, when you divide 250x squared by 2x squared, it gives you 125. And you can take the cube root of 125, class. 5. So we're getting 5 times the cube root of 2x squared. That adds together to get 7 times the cube root of 2x squared. Are there any questions on the first 6 homework problems? Any questions on the first 6?
What was 1 and 5?
1 you just can't add them, and 5 you just can't add them.
Oh.
Because they're not similar.
Oh. Yeah, that's why.
Yep. All right, Josh, any questions?
I don't think so.
All right, let's go and take a look at the pure quadratics now. And remember here, you want to get the letter by itself, then take the square roots, plural, of both sides. Number 7, you should have gotten positive -7. Number 8, positive -6. Number 9, positive -5. Number 10, positive -8. Number 11, positive -10. Now on this one, there's a k squared on both sides. Remember, we got to get rid of the little one, so we're going to subtract away the k squared to get 2k squared, equaling the 200, divide away the 2 to get k squared 100, then that's how we get the positive -10. And number 12 is just annoying. Positive -2 times the square root of 35. Let's take a look at number 12. Of course, the first thing we would want to do here is to go ahead and add the 10 to both sides. And of course, when we do that, it'll give us a c squared over 14 is equal to 10. And then, of course, we'll multiply both sides by the 14 to get c squared equals 140. And then we have to take the square root, and if you were to go back, you'd realize 140 isn't on that square root list, which means you're going to have to reduce it. But if you look at the last 2 digits, you should notice a 4 would go in. So you'd factor, well, I at least know there's a 4 there. 4 times what? Well, ends up being 35, and there's no other squares. No 4, no 9, no 16, no 25. So there we go. Positive -2 times the square root of 35. It is when we take the square root of both sides. Questions on 7 through 12?
I think I did number 8.
Number 8. We had a 3/4 y squared is equal to 27. Remember, Joshua, if I want to get rid of the fraction, multiply by the 4/3. But make sure you put the 27 over 1 so that here the 3's canceled, there the 4's cancel, I get y squared. Well, here the 3 and 27 cancel to get a
1 and a 9.
Which 9 times 4 becomes
30.
And that's where I get the positive -6 from.
Yeah, I think I just forgot. Yeah. I multiply by the reciprocal on one side, but not on the other.
Gotcha. So did you get positive negative 3 times the square root of 3? Yeah, remember what you do to one side, gotta do to the other. Good. Any other questions on the 7 through 12? Any other questions on 7 through 12? Any questions on adding radicals or solving pure quadratics? Or do we feel like we're ready for this?
So like on number 4,
Yes.
you can split the 40 into 4 times 10 to get 2 times the square root of 10.
Right.
And you can just add
The 2 square root of 10 they
other
gave, plus the other 2 square root of 10 you just got to get 4 times the square root of 10.
So both sides don't have to be reduced.
They don't have to reduce necessarily, no. No. All right, good. Any other questions? All right, let's do it. Clear your desk except for a sheet of paper, pencil. And I guess that's it. Sheet of paper and a pencil. Sheet of paper for a cover sheet. And we will take quiz 41. Quiz 41. Which doesn't actually mean it's the 41st quiz this year, because remember we skipped a chapter with all of its quizzes, and I added other quizzes that I made up along the way a few times. So, yeah, I don't know how many quizzes you've really had. Probably somewhere around 40-ish. All right. Paper, pencil, all you need out. Let's go and take a look at the quiz together. On the quiz, your first section is to just determine, are these similar? Now, you may have to simplify them first, but to determine, are they similar or are they not? Okay? And just write yes or no. Yes, similar, no, not similar in the blank. Numbers 4 through 6 can be made to add. So it's not a question of if. They can figure out how to make them add and then add them. And then for 7, 8, and I believe on the back 9 and 10, you've got some pure quadratic equations to solve. Should be plenty of room to work right there on the quiz copy. Again, first and last name in the name spot. Actually, I think I skipped that somehow. First and last name in the name spot, and it's 4/30/21, last day of April. 4/30/21, today's date. All right, you may begin.
Just